This
Uh,
conference will now be recorded.
all right, guys. So let me share. I think I'm already sharing. So we started with the inventory. We covered some portion of it. We understood the concept. So let's move forward uh, to the inventory part. Let me open the favorite. So yesterday we were also discussing, some uh, drivers of the safety stock from the demand perspective, from the supply perspective, right? So we'll see them in practical. We'll create some scenarios and then we'll see how they looks like. Let me do one thing. Let me filter out. So product ID. Let me take. Okay, this one. Okay, IBP 100. This belongs to the ABC category A, and this is at these locations. So this distribution centers, and let's see now. Let me also copy the same filter to the other tab. What is so I've copied the same filter here in the results as well. So one of the important parameter that when we run the inventory optimization, we do require the forecast error CV. So this, we have an app for the forecast error, as we have seen, couple of calculations in the earlier sessions that describes about, MAPE, MPE, all those, um, standard methods which used to calculate the error. So on the same logic, this error coefficient of variation is being calculated. And you will see that if this particular data is not there, this is one of the important, you can say, data in order to um, see the results for the inventory optimization. So for example, now if I just execute this IO in order to calculate the safety stock, so what we have learned is I can just go here, run. So I can do it from the Excel, and I can also, create a job. So let's say that we were talking about yesterday the multi-echelon, inventory optimization. So let me just give the filter here, IVP 100, and then run it. So I'll go to the status. is finished. Yeah, it's completed. And okay, so let's do one thing. Let me put some error CV. If we want, we can also calculate it from the system. Here we also have the opportunity to just calculate the error one. So if I just execute it for the same product, so here it is telling me that IO forecast error CV. So this one I can just use the same for IBP 100. And if the bomb is there, if this IBP 100 has several components, so inventory optimization will be calculated for all. So I've just executed the error CV first. Let me refresh it. So now we see here that it has calculated the error CV percentage for this product at different locations. So we have three distribution centers that this is associated with, and it has calculated for all. And 0.73 is the okay, 0.91 is the highest one. So at Hong Kong it is the highest one. So meaning if we execute the the safety stock, it should be more for this particular location, right? So at this moment, if we see that um, the recommended safety stock for Hong Kong location, it is 17, and uh, for other it is low. So let us just execute it, because now we have calculated the error CV percentage, so that figure may get changed. So let me go to the this profile again and then re-execute it. So let it complete. So now you see that the highest is at the Hong Kong, because the error percentage here it is more. So this is one of the deciding factor that the it will decide that how much of the safety stock has to be kept. So as yesterday we were discussing, what exactly is the objective that we are taking out of this is something like, so let's say that this is a um, our store. Let's say this is target, and so this is the customer, right? So now this customer can be sourced from, let's say, a distribution center, and then this distribution center can be backed up. It can get the goods from, let's say, uh, there are two plants. They are the manufacturing plants. So this is plant 1, this is plant 2. And these plants are again sourced, backed up by a warehouse. So this is a central warehouse which is, you know, uh, giving the raw materials to this plant, and then these plants are creating the finished goods and then giving it to the distribution center, and then this distribution center, the customer is being, picking up from here, right? So the whole objective of inventory target is, let's say the safety stock is calculated. So how much of the safety stock has to be kept in the distribution center, and how much at, you know, plant P1, and how much at plant P2, and how much stock should remain in the warehouse, right? So this is a problem statement, right? Then inventory optimization, when we execute it at each location, it tells us that how much safety stock it should be, right? So that's the objective of the inventory optimization. Not only for the finished goods, as Vinod was asking yesterday, it also calculates, for the components as well. So if you have a bomb, so we'll see that mass data in detail, when we go to the another subject, when we study the supply planning. So we'll see, the mass data like location source, production source header, production source item, all those stuff we'll see in detail. So for now, you just understand that if we have a supply chain like this, right, then objective to calculate the safety stock at each of them is, is being fulfilled by inventory optimization, right? So there are several factors which will help the algorithm to decide that how much here, how much here, how much here. So those factors, one of that factor is, uh, the lead time. The lead time decides, for example, if it takes more time from warehouse to plant, right, then we need to keep available more stock here. Or it takes more time from, the lead time from here to the distribution center. If the lead time is more, then we need to plan it, according to the customer requirement date. The goods should be, reaching to the distribution center, right, according to the lead time. If the lead times are long, we need to backtrack and then plan the shipping date of the products in that manner, right? So lead time is one. Another is, something called as PBR, the period between the reviews. So that's your order frequency, that how frequently you are ordering. So if you are ordering, let's say once in a week, then, or if you are ordering once in a month, then both will have the different scenarios, right? So all these things we'll see in detail, uh, maybe in upcoming ones. So first one, we were talking about the forecast error CV. So definitely if the error increases, the forecast error increases, the safety stock also has to be increased, right? We need to keep more safety stock uh, in order to fill the demand which would be coming up. So this is the part of the demand variability, right? So there are different kind of variabilities. One is from the demand perspective, another is from the supply perspective, right? So when we execute this algorithm, so system also can tell us that which variability is causing uh, more, um, you can say, variability in this safety stock calculation, right? So let me go back to the system, close, and then here what we can do is, so how the planners play around with this is, let me make some more space. Okay, so we can
So,
actually create the scenarios. Yeah.
HS, is there any way, or you have already covered, how does system calculate, let's say, row number 7, the coefficient of variance, variation 0.73?
Yeah, we will be talking about that. Yeah.
Okay, all right.
Yeah. So in the past, in the demand sessions, actually we actually covered that. So now the same thing as we were speaking, like the we have an app for this, which actually can help us to calculate this, and we also have an algorithm by SAP, which when we execute it, it just covered based on the same techniques what we have learned in the demand session, that is made all those standard parameters. It will come up with the error percentage of the coefficient of variance, right? So now if I want, I can also create the scenarios out of it. So I'm just clicking on create button, and I'll say, so, in demand session, Rajneesh, we actually, calculated with the formulas. We understood the formulas also, that how different, error methods are being calculated. All of them, what I've done is I've put an Excel as well in the SharePoint in our that Google Drive one, which has those formulas as well. So that may have made how all those calculations are happening. So we also had undergone a detailed session earlier part of time.
Okay, I'll check that out.
Yeah. So let me create this scenario as
But
coefficient of
apps work the same way because there are two different apps for forecaster, one for inventory and one for demand. So
yeah
both
yeah
work.
yeah exactly, yeah.
Okay.
So let's say that this is coefficient of variation. Let's consider the scenario, and let me take it as 0.99. Okay. So now this is scenario. So let me give um, here as 0.99 in one of the location called as Seattle, and the other location is Rotterdam 0.99, and the third one is Hong Kong 0.99. So let's see that on all the three locations we are creating a scenario with this one, and I'm just saving it. Now let me go to the edit view and say scenario. I can also take the baseline. So baseline will remain same with the old values what we had, and now what we are doing is we are just taking up the, okay, let me remove target service level for now, and then we'll bring it later. We'll bring it back later. So target service level. Yeah, so we have the baseline forecast. So the demand remains same, but if for this scenario CV1, we just have given 0.99 just to see that how uh, the safety stock looks like in this particular when we execute it without disturbing the baseline numbers, right? So that's the objective, that I do not want to disturb this, change this, and then see the impact and then change it back. So what I've done is I've created a scenario, right, which will help me to just decide that whether to go for it or do not go for it, right? So let me now execute uh, this one, run. So I'm now running it for baseline as well as my this scenario as well, CV1, what we just created for the product IBP 100. So now this recommended safety stock, once it is completed, what we should see for the CV1 scenario, it should be more, right? Because we have increased the rate of the forecast error, right? We have increased it to 0.99. Oh, okay, 0.99. Okay, we have increased it only for this location, Seattle. I think the other one didn't get saved. Okay, let me do again. So this one, error CV, let me also put as 0.99, and this one also 0.99. So let me save it again. Yeah, refresh it once just to verify. Yeah, and then rerun it. So I'll rerun both the versions. So baseline version and my scenario version, and I'm taking a filter here and run it. Status running. So here it is 62, 62, but now you see that for the CV1 scenario, it is increased, right? So CV1 is what? CV1 is with the 0.99 rate, it is this much, and with the baseline, it is less, right? So everywhere now it is giving more for the CV1 as compared to your baseline, right? So this is how it should actually we can see. So this is not only the parameter that that affects the safety stock, but the other one, there are other parameters as well from the demand variability perspective. So other one is the period between the reviews. So for example, uh, you know um, if you increase the PBR, it means the time taken to deliver an item at a given shipping point. If the order frequency is more, for example, you are ordering once in a while, then you have to keep more safety stock, as simple as that, right? So the safety stock will increase if your PBR is actually increasing, right? So PBR, you can define it as a part of master data. Either, I think this is at the location product level. Let us go and check. So let me give here the master data as location product.
It's a
Ah,
column. It's a column AS. Column AS.
column AS. Okay. Ah, okay. Great. So this is the one. So we have two ways to define this. One, we can bring it onto the master data here, and this is a key figure as an attribute as well. So we can define it as a key figure as well. So I can just bring it in my input section. Um, okay, let me first conclude this. For example, now if we are okay with the baseline results, we will ignore the scenario that we have created. But if we are okay with the scenario results that has given the recommended safety stock, and we would like to increase um, uh, you know uh, this much error percentage is the right one, for example, then I can upgrade this scenario to the baseline. So how can I do that? So this is not a good example to create the scenarios, but the same way we can create it for the PBR, because there we will see that if we increase the PBR, if we decrease the PBR, if we increase the lead time, if we decrease the target service level. So those are the good ones. We'll see those ones also. So for example, if I want to promote this, I can just go into the manage, and then I can just promote it. So promoting will help me to apply those changes I have to do. Then what it will do is, whatever the results are in the baseline for the recommended safety stock, Once I click that promote button and apply changes, so these results will be copied, uh, to the baseline. The scenario results will be copied to the baseline automatically if I do that promote changes. So I haven't done it as of now. And if I want to delete the scenario, I can again go to the manage, and to delete it, it is not coming up. I think because I have to remove it from the planning views. So that is what it is saying. So once I remove it from the planning view, then only I can delete the scenario. So just see that how do we delete it. So for example, now from here, first I will take it out because it should not be in use if I want to delete it. Because sometimes you might have to, delete some of the scenarios which you have created. So now it is enabled, and I can say apply changes. So that scenario will now no more be there. It's now deleted. So other thing, yeah, we were talking about the period between the reviews. That's the order frequency that we order it. So it is a part of the location product master data. So we'll see that, if I want to bring it in my this view as a key figure, so I can also bring it in the key figure. I'll just type, let me try PBR. Period between replenishment, period between reviews, anything you can call it. So this is at the product location, and this is editable in all time periods. It means that we can also save the data directly into the view. So now, this is the period between the reviews, and this is at this three plant, and again at this three DCs. So let me, if I increase the period between review for, let's say, this is the one associated with this location, and this is with Seattle. Okay, so I've increased it for uh, this location ID for the distribution center Seattle. I'm just saving it.
And it can be different for different periods too, right?
Yeah, exactly. So that's the objective of, the attribute as a key figure. If we want to keep it same, then we can just enter that value in the master data only once. That will be for across the horizon. So as we have seen in the location product master data, it is one now. So that one will be distributed to all the horizon as it is now. But if we want to keep it specific to, period, we have the opportunity to do that. That's why, we have configured it as an attribute as a key figure, so that both ways we can actually do it. Right, Rajneesh?
Yep, yeah, got it.
Yeah. Okay. Okay.
Because I was reading somewhere that
Okay.
a couple of months ago that even though we change vary the value for a period, uh, algorithm does not fix it up. But I'm not sure if it does because it's not so easy to really uh, understand the results of the safety stock, based on
Yeah. Yeah.
each of these.
Exactly. Let's try
Yeah,
that. So
yeah,
let me give here. Let's say here I'll give 4. Right. So
yeah,
now we
yeah.
have 2 periods. Let's see how it does.
Yeah. Based on my experience, it works, but not consistently. Or maybe
Oh,
sometimes
is it? Okay.
yeah, sometimes I go crazy with the output.
Ah, okay. Let's see that.
So, is there a recommendation for how long horizon you can have for a attribute as a key figure?
Now, what I've seen is, um, I don't see that planners are coming and then maintaining it uh, at the period level. This one, they
Mm,
maintain it at the maseta level. I mean, in projects I've seen, and that will be consistent for the horizon that they have. It means they will have it for the full horizon. So very exceptional cases I've seen that they go and then they change it period wise, the PBR or something,
mm.
until unless there is a need of it, but otherwise these things they keep it constant in the master data. So if they do it, they just come for the specific weeks, but you know I've not seen much such of the cases where planners are altering the master data at a week level, such master data which is the
No,
PBR kind of.
sometimes it does happen. I'll give you a simple example, right? So, take the case of lead time, right? If you're sourcing it from your own country, lead time may be probably in a couple of weeks. But if you're sourcing it from China or any Asia Pacific and it comes by sea, it goes up to 6 weeks. So I've seen a couple of customers doing the simulation, let's say, because the cost wise it is a huge difference, right? If you're sourcing from Asia Pacific, but they want to see from the IO perspective, what impact it would have.
Yeah, yeah, yeah. You are right. You are right. Yeah. So it depends on case to case basis
Yeah,
that they may want to go for it, but that will not be a regular practice. So it may happen, in some cases if they are very specific about it, they definitely can change it for the reason as you explained. Yeah, you are
yeah,
right. Okay. So I've just done it. Let's see now. So this one we have done it for cetal for 47 and 48. So now I'll just highlight it. This one, it seems to be same, right? Let me see that if that got finished. I think it is because I see the numbers got changed actually. Yeah, it is. And let me refresh it one more time. Yeah, I think yeah, this is the same it is giving for both. You're right. So for the cetal, if we see that for IBP 100, yeah, this is the same product, and we have given 2 and we have given 4 at this product and location, which is cetal, but it is still taking it as 84 for this as well. Yeah, but now it has increased the safety stock from the previous one because the period between reviews has been increased from 1 to it has doubled
yeah,
now to 2.
yeah. And
So
other
that's
reason probably you don't see the impact because your demand is too low. You have only for 2 periods.
why the demand for the this one, I actually I kept it same. For example, uh, I just wanted to see the impact. So
Yeah.
Here if you
No,
see that it is.
no. What I'm saying is you do not have a demand for longer horizon, right? So you have only for two
Aha,
periods.
okay, okay,
Yeah.
okay, okay. Yeah, yeah.
You'll see an impact, if you have a consistent demand over a period of time,
Mm-hmm.
then probably it will have more play
Correct, correct.
because
Yeah, yeah,
here there is nothing to plan for the future, so system does not care
yeah,
about
yeah.
PVR anymore.
Yeah, yeah, you are right. That may be the case. It's all declining in the future months. It's all
Yeah.
zero. Okay, yeah. And then we also have, the target service level. So let me bring that up. Target service level. Let me take out this. Okay. So, for example, how much target service level you are keeping, that is also one of the factor uh, that will decide your safety stock calculation. The more service level if you want to achieve, the more safety stock you have to keep in your stocking points, right? Let me save it. So let me say that I want to keep it as 90% and let it be 50 and 50. For the cetal I have increased the expectation to 90%. So it should keep high safety stock on cetal as compared to the Hong Kong and Rotterdam. So I'll just in now execute it again. So now for the cetal one, it should increase more as compared to the other one. Yeah, so according to the demand, it has increased to 270, but for the Rotterdam, it is still in 80s. And here, I think in Hong Kong, the demand would be more already. Yeah, so demand is in 1000 as compared to this, but still, comparatively, here the safety stock, according to the demand, it is suggesting that we need to uh, keep it high at CETA, which is 270. Right. So in these cases, we can actually, it makes sense to create scenarios for the planners and then they play around with it. And then, they will pick up the results which are suitable. So, uh, you know, because it is not a straightforward formula. So that's why scenarios in these cases helps a lot to the planners. They will do different runs with different parameters, and then take the decisions on their inventories. So this is about the TSL, and this is also one of the important parameter. We'll talk about this in supply classes as well. In case we are increasing the holding cost rate, so what does this mean? That, so for example, we have a chain. We had a customer here, and then customer is backed by one distribution center, and then distribution center is backed by two plants, like that, right? We had a supply chain, and let's say that um, the inventory holding cost for DC is more, then the system will decide to keep the stock at plant itself, for whichever reasonable duration it can keep, right? For example, if the lead time has come nearer and the stock has to be delivered, uh, not before that lead time, it will just push the stock to DC if DC is having more, inventory holding cost rate. So this is also, we can define it as a location product level or at a key figure as well, if you want to define different rates um, at this. So this is about uh, at which location, how much safety stock it has to keep. So one of the deciding factor is also the inventory holding cost rate. So either it has to keep on one of the plant or one of the TCs, like that. So we should have a key figure for this as well, which we can just change the rates and then run it again. Sorry. uh, Something happened. Oh, okay. Inventory holding cost rate, this is the one which, so in the mass data it is 1, so it is coming as 1 across this one. So let's say that for one of the plant, if we increase it, um, then we will see that it, let's say for that cetal, if we put this inventory holding cost rate to, let's say, 5, then what it will do is, let's say for this uh, December, till December period, we have a high inventory holding cost rate for cetal distribution center, so it will try to avoid keeping the safety stock here, and it will suggest that other plants should carry that, the stock, because there the inventory holding cost rate is less. So these kind of scenarios we'll see in detail when we are into the supply planning. So what we'll do is, we'll create our own example. For example, if we want to manufacture a iPhone or something like that, and we require some components out of it, right? So components also, so we'll create our bomb, and then we'll do this exercise in more detail there. So here, if we want, we can just simply save it, and in the same way we can just run it. So we'll see the impact of the inventory holding cost rate, but we'll see with a proper example when we are in the supply scenario for this. Yeah. These are few factors, along with the concepts that we have understood, a few factors which will be driving the safety stock calculation. And also at the component level, if we want to execute, for example, if I just go to run, and different IC components as well, if I want to execute, like we were discussing several kind of stocks yesterday, I can always go to the target inventory components and then execute it. So it will show me all those different stocks, like the uh, uh, pipeline stock, and then we have in transit stock, all that it will just show the cycle stock, right? All this kind of different stocks as well we see. But the main aim you will see here is the safety stock. The people use the IO actually. So that is it. I want to briefly cover about the inventory optimization. So now we will go a little bit in depth and see from the supply perspective that how these scenarios works from our next class, guys. So we'll develop the master data from the scratch. We'll create our own products, and we will develop the whole master data, that what all we required to execute such scenarios. And then step by step we'll go in depth to run couple of other scenarios as well from the supply perspective now. All
Yeah.
right. Yeah, Jay.
Okay, HS, would you have any calculation for recommended safety stock?
I don't have it, Rajneesh. So nobody has even asked me to do that. So do you actually need it for your project? Do you really, the
Yes,
users are
actually,
asking?
my
Okay.
users are really interested to know. Actually, I asked SAP. SAP refused. SAP also says,
No, no, SAP, that's the problem, right? With
mm,
SAP, they
mm,
keep some things as black box, and some of the things they hype a lot.
yeah,
They very openly demonstrate it, but things like safety stock, I don't know, uh, are there any diamonds hiding in it? So they don't reveal the formulas and all very easily. But let
yeah.
me see, yeah, let me talk in the team as well. If someone has any clues, I will just come up, but don't keep much hopes on that. But let's see if we can get it. Yeah.
No, I have already set the expectations, but I'm still not given up on on
Yeah, yeah. Okay, okay. Yeah.
finding some more details on the calculation if you can find something. I'm trying to use some industry best practices, but SAP has its own algorithm, so
Correct,
uh,
correct. Yeah.
it's crazy, but that's how it is.
Yeah, exactly. I think if you even try, the textbook formulas and all, that may not very straightforwardly works, to give the exact results as the algorithm is showing.
Correct.
So yeah, so that's the actually problem. But yeah, let's hope. Uh,
Yeah.
let's hope and see if we can
Yeah.
get something around there. All right, guys.
Well, thank you.
Yeah,
And do
thank
you
you.
have this presentation on the server as well?
Yeah, yeah. So now we have finished it. So I'll keep that. So as and when we are finishing the topics, that Google Drive documents which you have seen the folder last time, right? That keeps on.
Mhm.
I keep on updating that.
Okay,
Yeah, yeah,
that's cool.
yeah, yeah. So there is also IBP 400. So that also I'll just keep it there for inventory optimization in the same folder, guys.
Okay, okay, sounds good.
Yeah. All right then. take care, and then happy festival, and then talk to you in the next session.
So
Bye.
tomorrow we having class.
Yes, yes. Tomorrow, I think these guys have not said no, so we can continue. Do you have any
Okay, then.
plans?
Yeah, I was planning to go out somewhere